Hello! In this video I'm going to be going over predicting products, focusing mainly on synthesis, decomposition, and combustion reactions. So we got a nice little note sheet right up here. It says it would be highly suggested to memorize these various happenings. If you don't, the test is going to be very difficult. So when H2O is a reactant, it produces a hydroxide, which is a cation with an OH, a base. So doing an example of this, it says when H2O is a reactant, it produces a hydroxide. So H2O is a reactant, and we're going to add, let's say, calcium oxide, CaO. So if you see this, you know right away a hydroxide is formed, so that's OH something. And we've got O, we've got H, we've got O, so the only thing not O and H is calcium. So we have a calcium hydroxide. Ca is 2 plus, hydroxide is 1 minus, crisscross it, and it's a 2 over there. 2 goes there, 1 there. Alright, and then we have to balance it. So we have calcium, calcium, 2 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens, and it's balanced. Another example would be H2O plus K2O, and these react to form, since we have water as a reactant, a hydroxide. And the only other element we have is potassium, so it's going to be potassium hydroxide. And this is plus, and that's minus, so it's an overall 0 charge. 2 potassiums, so we have 2 right there. 2 O's, 1, 2 O's, 2 H's, and 2 H's, and it's balanced. So these would be synthesis reactions because they have 2 reactants and 1 product. And since water is a reactant, a hydroxide is formed. Alright, moving on to another type. When a hydroxide decomposes, it forms H2O and an oxide. So when a hydroxide decomposes, it forms H2O and an oxide. This is virtually the same thing as these two equations, only flipped. So if we had CaOH2, only 1 reactant, and we're going to have more than 1 product, therefore it's decomposition. We're going to have water as a product and some sort of oxide. So here's O and H. The other element that would be bonded to this oxygen is calcium. So it would be CaO. Alright, and it's balanced. So next one, what do we have? KOH. This reacts, decomposes to form water and some sort of oxide. And the only other element that could be with it is K. Looking at this, so predict products. Second step, make sure we have a 0 charge. 1 plus, 2 minus, crisscross it, K2O. Now we have to balance it on both sides 0. 2 potassiums, 2 potassiums, 2 oxygens, 1, 2, 2 hydrogens, 2 hydrogens, and it's balanced. So these are decomposition reactions. If you have a hydroxide, it will decompose to form water and an oxide. Moving on to another type of problem. ClO3 decomposes to form O2 gas. So it decomposes to form O2 gas if you have a chlorate. Alright, doing an example, let's say we have KClO3. This is going to decompose to form O2 gas and a chloride. So it always forms O2 gas and a chloride. So here we have 1 potassium, 1 potassium, 1 chlorine, 1 chlorine, 2 oxygens, 3 oxygens. So put a 2 in front of that, 3 in front of that. 2 times 3 is 6, 3 times 2 is 6. 2 KCl, 2 KCl. Doing another example, let's find another chlorate. Why don't we do magnesium chlorate? This is going to, again, form O2 gas and a chloride, MgCl, 1 minus, 2 plus, crisscross it, MgCl2. 3 times 2 is 6. So we're going to need 3. We're going to need 2. 3 times 2 is 6. 2 times 3 is, oops, cross that out. We don't need that because we have 6. And we have 2 chlorines, 1 Mg, 1 Mg, and it's balanced. So the main idea, if you have a chlorate, ClO3, it's going to decompose, form O2 gas, and a chloride, in this case, MgCl2. Alright, going on to the next one, CO3 decomposes to form CO2 gas and an oxide. So it's carbonate. So why don't we do common one, calcium carbonate. If you have this guy, it's going to decompose to form CO2 gas and an oxide. So we got CnO, CnO. Calcium is the only other thing to bond with this oxygen to make an oxide. 2 minus, 2 plus, it's overall 0 charge. 1 calcium, 1 calcium, 1 carbon, 3 oxygens, 2, 3 oxygens, and it's balanced. Calcium carbonate decomposes to form CO2 gas and an oxide. Alright, doing another one, why don't we do, I don't know, Na2CO3. Sodium carbonate. Again, decomposes, forms CO2 gas and an oxide. Na is going to be with that oxygen. 2 minus, 1 plus, Na2O, Na2, and it's balanced. A carbonate decomposes to form CO2 and an oxide. Alright, moving right along. An acid reacted with a base forms salt and water. It's this guy right here. Acid plus base equals salt plus water. And this is going to come back in the last unit, the acid-base unit, and it's going to become like second nature at that time. But going over it now might pop up on the test. It's a type of double replacement reaction, and it's called the neutralization reaction. So we have an acid, say HCl, and we have a base, let's say NaOH. Now remember, if it starts with an H, it's an acid. So this guy is an acid. If it has an OH in it, it's a base. But we'll talk more about how that's not always the case. Sometimes bases don't have an OH, but a general rule of thumb, if it starts with an H, it's an acid. If it has an OH, it's a base. Alright, we're going to do a switcheroo. The cation switch, the H and the Na switch. So we're going to have NaCl plus HOH, also known as H2O, salt plus water. Another way of doing it would be, let's do another one, H2SO4 plus KOH. I'm writing equilibrium arrow. We're going to talk about that in a later unit. I'll just write a regular arrow. H2SO4 plus KOH. So what I do is I circle the OH of the base and the H2 of the acid. So the H of the acid I circle, the OH of the base I circle. That's my water. Yes, I know there's 3 H's. That's going to get fixed when I add coefficients to balance it. That gives me K and SO4. Positive one always gets written first. That's K. And we have SO4. And on my polyatomic ion sheet, SO4 is 2 minus. Potassium is in the first column, so it's 1 plus. Crisscross it, and you have K2SO4. Alright, so I predicted the products. I made sure my overall charge is 0 for the molecules. I now have to add coefficients. So I put a 2 in front of the KOH. That gives me 2 Ks. To match my 2 Ks here. I have 2 O's, so I need a 2 in front of the H2O. 2 times 2, 4 hydrogens. 2 plus 2 hydrogens, and it's balanced. And that's an acid-base neutralization reaction. It's a type of double replacement. And moving on. Alright. Metals form alloys, which are mixtures. That's this guy. Alright. These are the easiest ones, because it's something like Na plus Fe equals, you have 2 metals, this one's plus, this one's plus, they don't mesh, they are not going to react. They may mix, but they will not react to form anything new, so you'd write no reaction. What if you have copper plus silver? Two metals? Again, no reaction. So anytime you have two metals reacting together, you're going to have no reaction. How about if you have lithium plus H2? So hydrogen is positive charge, lithium is a positive charge. Again, no reaction. Alright, moving on to another one. We have combustion reactions, and there are two types. There's complete combustion and incomplete, and this is the last one. These are fairly simple once you get the hang of it. Combustion reactions always have O2 as a reactant, and they're also going to, in most situations, produce water as a product, and also CO2 or CO as a product. If it is complete combustion, CO2 would be produced. Incomplete combustion, CO would be produced. So doing an example, we have C2H4 plus O2. So I have O2 as a reactant. Oops. Let's get this out of the way. I have O2 as a reactant, C2H4 as a reactant. This is a carbon-based molecule because it has carbon in it. I'm going to react it, and it forms always water plus CO2 if this is complete combustion. So then really it just becomes a balancing problem. Two carbons, 4 hydrogens, 2 times 2 is 4, that gives me 2, 6, 3 times 2 is 6, and it's balanced. That's complete combustion. What happens if I have C2H4 plus O2 and this is incomplete? Incomplete combustion. I still have H2O as a product, but this time my other product is carbon monoxide, CO. I need 2 carbons, 2 hydrogens, 2 times 2, 4 is 4, 2 plus 2 is 4, 2. So the only thing that really changes is my product is CO instead of CO2, and my amount of oxygen is different. Doing one more. We have CH4 plus O2. This reacts to form, again, water, and let's say we're doing complete combustion. It's CO2. 1, 1, 4, 4, 2, and 2. And it is balanced. So there's some situations where you have a combustion reaction and it does not have a carbon-based molecule, like H2 plus O2 reacts to form H2O. This would be a situation in which we just have water that's formed. And we do that and that to make it balanced. Alright, so in order to really be successful in predicting products and balancing the equations, you just really need to practice it. Practice, practice, practice is of utmost importance for success in understanding this concept.